Hello, my name is Saurabh. I am a performance engineer at Red Hat, where I work on XTP and BPF use cases. So I'll be going over what BPF and eBPF are and how are people using eBPF in their daily routine and maybe in the data centers or in their servers. So then I'll also be sharing a practical real life scenario, which is DDoS mitigation. And I have compared and did some runs with XTP, which is basically an eBPF program, and compare it with IP tables and IP tables ROM mode. And yeah, so so what exactly is BPF? So BPF is a in-kernel virtual sandbox, in-kernel sandbox virtual machine. So what it means is it lets you run arbitrary user space code inside the kernel and hook into various kernel components. So unlike kernel modules, it is much safer as it is running inside a sandbox environment and it doesn't require rebooting. So BPF was created when along with TCP dump. So TCP dump basically compiles down to BPF and runs inside a sandbox virtual machine. And basically, it only add two registers. So people at Plumgrid in a few years ago thought about that we should extend it, and as they had a specific use case for an SDN product, so they increased it from 2 register to 10 register and added various other features, which boosted its performance a lot as compared to BPF. So nowadays, whenever you talk about BPF, people mean BPF. As also TCP dump now compiles down to eBPF and not BPF internally. Yes. So BPF is actually Berkeley packet filter. So the older one is now referred to as classic BPF, and the newer one is now referred to as only BPF. So I'll be talking about some use cases of eBPF, such as networking. So some of them are in production, run by various companies, such as DDoS mitigation is run by Cloudflare, and load balancing is used by Katran. So Katran is a product from Facebook, so they have already deployed in it on their some of their data centers. And Cilium is another use case which is used for network security and setting up layer 4 to layer 7 network policies for Kubernetes. Yeah, then I'll be talking about XTP. XTP is a high performance network data path. So it's part of the kernel from, I think, 4.8. And it lets you work along with the network stack. So for example, when a packet reaches your network driver, it will first have to go all the way to layer 3 and consumes a lot of memory and processing just to be dropped, if the packet is to be dropped according to the IP tables rule. So some people thought that instead of having the packet go all the way up and consume that much memory, why not just have the processing done just before when the packet arrives? So that's what XTP is. So it basically allows for very fast packet processing as compared to IP tables. So yeah, I'll be showing some data and some numbers on how well XTP performs and how people can use it, and when to use it, and that's also. And then I'll be exploring another use case, which is tracing, which lets you say you want to explore what's happening inside the device driver. So you can run a eBPF program to check how many hard interrupts are happening. Or maybe you want to check how many how many files have a process open. So things like that. Yeah, and I'll be sharing how you can write an eBPF program and what is the architecture of an eBPF program look like and how you can create one.